Good morning, students. Welcome back. This is your geography lecture, and we'll be continuing with chapter 2 of geography. In the last lecture, we completed part 2. Now, this is part 3, the interior of the earth. Let's do a short revision of what we have learned in the previous video. So in the previous video we saw that the earth is divided into many parts, mainly the crust, mantle and the core. We also discussed about the various layers, the continental crust, the oceanic crust, then the asthenosphere, etc. Today we are going to discuss about the last layer or the most interior of the earth, that is the core. Okay children, let's start. The core starts from around the depth of about 2900 km from the earth's surface. The part of the earth's interior extending from the mantle up to the center of the earth is the core. The thickness of the core is about 3471 km. This layer can be divided into inner core and outer core. Now see children, the layer which extends from mantle to the core or to the center of the earth is known as the core. Now, core also is divided into two parts, the inner core and the outer core. See in the picture you can see two cores, one is liquid and the other is solid. Let's see about the outer core first. The outer core extends from around 2900 km to 5100 km. The secondary waves cannot pass through the core. They get absorbed in this region. This has led to scientists to believe that the core could be liquid or semi-liquid in nature. Now children, as you all have learnt in the lower classes that the secondary waves cannot pass through a liquid medium, and that is why it is believed that the outer core is liquid or semi-liquid in nature. Now the primary waves travel through this layer. As secondary waves cannot pass through this layer, but still the primary waves pass through this layer, but their speed reduces while passing through this layer. The density of the outer core is 9.8 gram per cubic centimeter. The temperature of the liquid outer core is around 5000 degrees Celsius. Now see children, it's 5000 degrees Celsius means it is very hot, and maybe that is the reason why it is in the liquid or a semi-liquid state. We have learned that the outer core of the earth's interior is in a liquid state and the proportion of iron is more in this layer. Vertical currents originate in this liquid layer. See in the picture you can see vertical currents, arrows which are shows the vertical currents. This is another characteristic of this area. The difference between the temperatures of the outer and the inner core gives rise to vertical currents. The Earth's rotation gives them eddy or a circular motion. Eddy means circular in shape. Electric currents develop in these spiral eddies of liquid iron, and thus magnetic field is generated. It is sometimes called the geodynamo. So now these electric currents which are developed in these spiral eddies of the liquid iron, and thus these magnetic fields are formed. It is sometimes called the geodynamo. So what is geodynamo? It is nothing but the spiral eddies of liquid iron which are formed due to this electric currents. This magnetic field of the earth is functional even outside the earth's surface for quite a distance. As a result, a cover develops around the earth because of the magnetic field. The earth's atmosphere is protected from solar winds coming from the sun. See in the picture, you can see how these winds are coming towards the earth. The magnetic field thus developed around the earth is called magnetosphere. So there you can see a magnetic field also. See the color in red, the circular field, that is known as the magnetosphere. So what is magnetosphere, children? The magnetic field thus developed around the earth because of the solar winds coming from the sun is known as magnetosphere. This is the fifth and an important sphere of the earth. For deeper understanding, I have inserted one more video, a reference video from NASA. Just go through it and try to understand.
Earth's magnetosphere. Presented by Science at NASA. Enveloping our planet and protecting us from the fury of the sun is a giant bubble of magnetism called the magnetosphere. It deflects most of the solar material sweeping towards us from our star at 1 million miles per hour or more. Without the magnetosphere, the relentless action of these solar particles could strip the Earth of its protective layers, which shield us from the sun's ultraviolet radiation. It's clear that this magnetic bubble was key to helping Earth develop into a habitable planet. Compare Earth to Mars, a planet that lost its magnetosphere about 4.2 billion years ago. The solar wind is thought to have stripped away most of Mars's atmosphere, possibly after the red planet's magnetic field dissipated. This has left Mars as the stark, barren world we see today through the eyes of NASA orbiters and rovers. By contrast, Earth's magnetosphere seems to have kept our atmosphere protected. Eftahia Zesta of the Geospace Physics Laboratory at NASA's Goddard Space Flight Center notes, if there were no magnetic field, we might have a very different atmosphere left, without life as we know it. Understanding our magnetosphere is a key element to helping scientists someday forecast space weather that can affect Earth's technology. Extreme space weather events can disrupt communications networks, GPS navigation, and electrical power grids. The magnetosphere is a permeable shield. The solar wind will periodically connect to the magnetosphere, forcing it to reconfigure. This can create a rift, allowing energy to pour into our safe haven. These rifts open and close many times daily, or even many times hourly. Most of them are small and short-lived. Others are vast and sustained. With the sun's magnetic field connecting to Earth's in this way, the fireworks start. Zesta says, the Earth's magnetosphere absorbs the incoming energy from the solar wind and explosively releases that energy in the form of geomagnetic storms and substorms. How does this happen? Magnetic lines of force converge and reconfigure, resulting in magnetic energy and charged particles flying off at intense speeds. Scientists have been trying to learn why this crisscrossing of magnetic field lines, called magnetic reconnection, triggers such a violent explosion, opening the rifts into the magnetosphere. NASA's Magnetospheric Multiscale Mission, or MMS, was launched in March 2015 to observe the electron physics of magnetic reconnection for the first time. Bristling with energetic particle detectors and magnetic sensors, the 4 MMS spacecraft flew in close formation to areas on the front side of the Earth's magnetosphere, where magnetic reconnection occurs. MMS has since been conducting a similar hunt in the magnetosphere's tail. MMS complements missions from NASA and partner agencies such as Themis, Cluster, and Geotail, contributing critical new details to the ongoing study of Earth's magnetosphere. Together, data from these investigations not only help unravel the fundamental physics of space, but also help improve space weather forecasting. For more on the active space that surrounds the Earth, stay tuned to science.nasa.gov.
So children, I hope you all have got a clear idea about the magnetosphere. Now let's move to the next topic, that is the inner core. The inner core extends from around 5,150 km to the depth of around 6,371 km, that is till the Earth's center. It is the core of the Earth which is in a solid state. Now see children, we saw that the outer core is in semi-liquid and liquid state, but now you see that the inner core, as you move deep inside till the center of the Earth, you find that it becomes or it solidifies. The inner core is in solid state. The density of this sphere is around 13.3 gram per cubic centimeter. Iron and nickel are the major elements found here. Now see, you can see on the screen, so the solid portion looks somewhat like this. So mainly iron and nickel are the major elements which are found in the inner core. Therefore, it is also known as knife. Now why children do you think this layer is called knife? Because iron and nickel are present in this particular layer, and iron is known as Fe, or the chemical symbol used to represent iron is Fe, and for nickel it is Ni. So when you combine these two, it becomes NiFe. So that is the reason why it is known as knife. As the materials in this layer are under extreme pressure, the inner core is in solid state. The temperature here is almost equivalent to the surface temperature of the sun. Just imagine that it is said that the temperature in this core, in the inner core, is equivalent to the surface temperature of the sun, children. So this is all about the Earth's interior. Let's do a short recap of what you all have learnt in the lesson. The structure of the Earth, the inner core, outer core, mantle and crust, the Earth's layers. The Earth was formed out of solar system itself. Initially, the Earth was very hot and in a gaseous state. While rotating around itself, the Earth cooled down and solidified. The process of the cooling down of the Earth began from the outer surface towards the Earth's center. As its effect, the outer surface or the crust is in the solid and cooler state. Crust and mantle and core are the three layers of the interior of the Earth. On the basis of the magma, gas and steam coming out of the volcanic eruption, it is inferred that the Earth's interior is hot. To know more about the Earth's interior, we saw that man has dug deep boreholes and came out with many of the findings also. We learned that the crust is divided into two parts, continental crust and oceanic crust. We learnt about the Sial and Sima. Then we learnt about mantle, the asthenosphere. Finally, today's video we learnt about the core. So here we come to an end of the lesson. Now children, kindly note the pictures or the images which I have used in the video are just for reference purpose. You have to go through the textbook and then you have to see whatever information is given in the textbook, that is to be used. Okay. Any doubts, you can join in the doubt clearing session. Thank you. Have a nice day.